about
Oh,
continuity.
Miss,
Yeah.
what are the practice sets we can use for the discussion group?
I honestly don't remember off the top of my head. If you look at the collaboration page, it will tell you.
Okay.
But I want to say, I don't remember the numbers, but the horizontal asymptotes, like the limits at infinity, could be used for this one, or the entire continuity practice set.
Okay, thanks.
Yeah. But if you look at the collaboration page, it'll tell you the practice set numbers and the exact problems from them that you can do. Okay, so we're gonna just do a couple problems that are similar to the problems we were working on Monday, and then I want us to add a layer of difficulty to this continuity thing. So we're really just gonna start off with something that we've already done here, and that is f of x is equal to x plus 3, 5, voila. So we have this function f of x, and we want to find and label all discontinuities. So we're going to start off by remembering that we had separated this into two steps. So we have step 1 here, and step 1 is looking at each of the functions, and step 2 is looking at the breakpoint. So in this case, I have one breakpoint. That breakpoint is 2. And therefore, we'll start just by thinking of which do I go to for 2 from the left, the top, the bottom, or the middle?
Bottom.
The bottom, you got it, Kenzo. So 2 from the left, and then 2 from the right will be the top. And when do I use the middle one? Exactly, at 2. So this will be like f of 2 only, because that's where it equals to 2. So we're going to start with our step 1 here, where I want to look at each of my separate functions. And what we saw is that what we're looking for is division by 0 or a negative under the square root. Is there any division by 0 here? Is it possible to have an x value that would cause division by 0? No, there's no fraction, there's no denominator, there's no x I could plug in that would cause a 0 in a denominator that's not even there. There's also no square root, so this is no division by 0, no square root, this is continuous everywhere. Everywhere. Then we look at 5. 5 also is the same thing. No division by 0, no square root, nothing. So this is also continuous everywhere. I just realized that I wrote a 3 there. That's supposed to be a 1, guys. That might happen more than once today with my head feeling like it does. Sorry about that. Okay, so the next one that we have to look at is x squared, x squared plus 4x plus 3 over x plus 1. So here I do have possible division by 0 because I have a denominator. So that division by 0 will happen when x plus 1 equals 0. In other words, that x is equal to -1. Do I care about that -1? What interval am I on? X less than 2. So this is on x less than 2. Is -1 less than 2? Yes. So do I care about it? Yes, you got it, exactly. So it is less than 2. I care about it. So what that means is f of -1, when I plug in -1, I get division by 0, which means what about f of -1? It's a discontinuity for sure, but f of -1, what will we write the answer is? If I ask you, what is f of -1, what will you write? You got it, D and E. This does not exist because that -1 is not in the domain. So then we want to check the limit to identify the type of discontinuity. So I'm looking at the limit as x approaches -1 of x squared plus 4x plus 3 over x plus 1. So notice this is like a mini version of question 1 from your web work. So like, in other words, question 1 from your web work is just this part of this problem. We identified where the denominator equals 0, and now we're evaluating that limit. So this is just like a much bigger problem than that question 1. When I plug in this -1, what do I get? I get 0 over 0, good job. So that means I want to do something else. I'm looking for a factor of x plus 1. I already have it in the denominator. I'm gonna have it in the numerator. What's the other factor gonna be? You got it, x plus 3. So then I can cancel out those x plus 1s and get that the answer is 2. So the limit as x approaches -1 of f of x is equal to 2. But the function is not defined there. So our expectation is 2, and there is no reality. What kind of discontinuity does this mean I have? We have this expectation of 2. Imagine what that looks like in your heads, but there is no reality. Good job, Marino. That means it's removable. I'm going into 2 on the left and right sides, but I never get there. I have that hole instead. So x equals 2, I'm sorry, x equals -1 is a removable discontinuity. Okay, so now I'm done with step 1. I found one discontinuity in step 1, and I'm moving on to step 2. And in step 2, I'm evaluating the limit as I approach 2. So as I approach 2 from the left of the function. But we already said that 2 from the left is just x plus 3. So this is the limit as I approach 2 from the left of x plus 3, and I get that the answer is 5. I'm sorry. Wow, not x plus 3. Oh my God. My head hurts, guys. I'm sorry. 2 from the left. Which function do I go to for 2 from the left? Do I go to x plus 3? No, I go to the bottom function. My bad. So I get x squared plus 4x plus 3. Clearly, you guys have to be paying super attention today because my brain is not at its best. Over x plus 1. And when I plug in here, I get 15 over 3, which is 5. Then I have the limit as x approaches 2 from the right of f of x. And 2 from the right, that's when we go to the top function, x plus 3. But notice I'm still just plugging in 2. And I get 5. So the left and right are equal. This doesn't actually tell me anything because I need to know what f of 2 is. In order to be continuous, remember, The limit has to equal to the reality. The expectation has to equal to reality. Right now, we've just found out that our expectation is 5. What's the reality? The reality is also 5. So are all 3 of these things equal here? What does that tell me? What's going on at x equals 2? You got it. All equal. So that means it's continuous. So f of x is continuous at x equals 2. So what we've seen so far is that a breakpoint can be an infinite discontinuity. It can be a removable discontinuity. It can be a jump, but it can also be continuous. Okay, now I'm just gonna do a simple example where I really don't change anything except that 5. So what if I had the same function pretty much? So I have the same function, but instead of having 5 there, I had a 4. So the only thing that changed from the above and this, I'm gonna just zoom out a little bit so we can see it all at the same time. The only thing that changed is that instead of having a 5, I had a 4. Is this continuous at x equals 2? No. What kind of discontinuity will it have? You got it. It's gonna have a removable discontinuity. So, no. It will have a removable discontinuity at x equals 2. So it has a removable discontinuity at x equals 2, and this is because h of 2 is equal 4, but the limit as x approaches 2 of h of x is equal to 5 as seen above. So in this case, it's a removable discontinuity. We were able to remove it by just replacing that 4 with a 5. Okay, are there any questions about this? Good. Okay, so we're gonna do one more question that's similar to this. And then, like I said, I'm gonna add one little thing, and we're just gonna do one problem like that before we call it a day. Okay, so we're still finding discontinuities. We still have our step 1 and our step 2. I'm going to start off, my breakpoints, I have 2 of them, are -1 and 5. I'm going to start off just by labeling where we have those breakpoints from the left and the right. Okay, so for our step one, are you guys ready? For our step one, we're looking at each of the individual functions and we're checking for division by 0. So I have x squared minus 4 over x squared minus x minus 6. To find division by 0, I set the denominator equal to 0. And we just need to factor this thing. So we need two numbers that multiply to give -6 and add to give -1. So in this case, we actually have to factor. We're not given, we don't already know a factor. We got to do it on our own. So two numbers that multiply to give -6 and add to give -1 would be what? You got it. So I'm going to have an x minus 3 and an x plus 2 equals to 0. So minus 3 times 2 is equal to -6. Minus 3 plus 2 is equal to -1. And now each of those gives me its own value. Do I care about both of them? Or can I get rid of one of them? And if I can get rid of one of them, so can I get rid of -2? Is -2 less than -1? This is what I'm asking. Yeah, so I'm getting rid of +3 because if I write 3 less than or equal to -1, that's not true. But -2 less than or equal to -1, that is true. So I'm getting rid of 3. But that means I care about x equals -2. And same as before, this tells me that f of -2 does not exist because it causes division by 0. So now I'm evaluating the limit as x approaches -2 of x squared minus 4 over x squared minus x minus 6. And I get 0 over 0, so I'm looking for an x plus 2. And we've already factored the denominator into x minus 3 times x plus 2. And the numerator is a difference of squares. So there we go. I have my x plus 2's. I can cancel them out. And I end up with -4 over -5, which gives me a +4/5. And I feel like I maybe just went through that a little bit fast. Did you guys follow and stay with me? So what does this tell me? What kind of discontinuity do I have? Because it's -2 minus 2 to give me a -4. So what kind of discontinuity do I have here? I have my limit exists, I have that expectation of 4/5, but there is no reality. You got it, Usman. So x equals -2 is a removable discontinuity. Guess what? We're not done with step 1. That was only the first function from step 1. So the second function, there's no possible division by 0. The only thing in the denominator here is 4. So no division by 0, no square root. This is continuous everywhere. And so then we look at our last function, which is negative 9 over x squared minus 7x plus 6. Here, we do have some things in the denominator, so we're trying to figure out where we have division by 0. So we're going to set the denominator equal to 0. And again, that means in this case, I'm going to have to factor. But this time I need two numbers that multiply to give me positive 6 and add to give me negative 7. What could those two numbers be? So I want the multiplication to be a positive 6, and I want the addition to be negative 7. We can start off with 1. You got it. There we go. Negative 1 and negative 6. So like 1 times 6 gives me a 6. So negative 1 and negative 6 will be the thing for me. So x minus 1, x minus 6 is equal to 0. So I get x is equal to 1 and x is equal to 6. And here we're on x greater than or equal to 5. Can I get rid of none of them, one of them, or both of them? I can get rid of the 1. 1, if we say 1 greater than or equal to 5, that's just not true. Whereas 6 greater than or equal to 5, that is true. So f of 6 does not exist. So then we want to do the limit. The limit as x approaches 6 of f of x, so of the function that we're at, x squared minus 7x plus 6. And when I plug in, I get negative 9 over 0. What does that negative 9 over 0 tell me?
That it's an infinite discontinuity.
That it's an infinite discontinuity. This can be infinity, it can be negative infinity, or it can be does not exist. So that constant over 0 said it's actually not removable this time. X equals 6 is an infinite discontinuity. Which brings us to our step 2. And in our step 2, we have 2 breakpoints. So we're going to start with the first one, x is equal to negative 1. So we start with the left limit. But we already looked at this and said, for the left limit, I'm going to my top function. If you guys still need that bottom, don't worry, I'll go back to it in just a second, but hopefully you're caught up with me. So here I get 1 minus 4 over 1 plus 1 minus 6, and that gives me a negative 3 over negative 4, which is positive 3/4.
Miss,
Yes.
you put in the limit thing you put it as -6, but above it's +6.
Did I write a -6? I would not doubt myself.
You see it?
No, I don't.
It's like where you write like the limit 1 to like the left, and then you start writing the function, like where you're doing the calculations.
Yes, I still don't see it.
It's
Okay.
like
So, okay, wait. Below or above this line that I just drew an arrow
no,
at?
it's to the exact left of the line.
To the exact left of
Exact
the
left,
line.
yeah.
Oh, are you talking about here?
Yeah.
Okay, that's supposed to be negative because we replaced it with the first function. So the denominator of that
Okay.
function is
Oh, I
x
can't
squared
see.
minus x minus 6.
Okay, I have my chat thing blocking the way. That's why.
-2 actually, so I couldn't see it on the screen either. Okay, so then from the right, we said -1 from the right, that's 1/4 x plus 1. So again, I'm still going to do 1/4 times -1 plus 1, and that gives me 3/4. These are equal, which means that I need to look at f of -1. What is f of -1? Am I plugging into top, middle, or bottom function? I'm plugging into the top function, you got it. So I have the 1 minus 4 over 1 plus 1 minus 6. That gives me a 3/4 as well. So all of these are equal, and what did we say it means when they're all equal? You got it, doesn't it? That it's continuous. So f of x is continuous at x equals -1. So this technically isn't part of the answer. That said, we had to check -1 because it was a breakpoint, and we found out that it was continuous there. So that doesn't mean it's not continuous in lots of other places. It just means that that particular breakpoint didn't cause a discontinuity when it had the possibility of doing so, right? But if I were to ask you, is this continuous at like 7? The answer is yes, because 7 is not a breakpoint and 7 didn't cause division by 0. So this is really continuous everywhere, except right now at -2, 6, and 6. We said maybe it's also not continuous at -1, but then we found out it was. Now we have to check what's going on at 5 because that's another place where we have a possible discontinuity. Does that make sense? So let's do x equals 5. And then after we do this, I'll write down what I just said because it's kind of an important concept. So prime from the left we said is the middle function. So that's 1/4 x plus 1. So that's 5/4 plus 1, which gives me a 9/4. And then we do 5 from the right. And we said 5 from the right was the bottom function. Ooh, what's happening there? And when I plug in that 5, I get -9 over 25 minus 35 plus 6, which gives me a -9 over -4, which is a positive 9/4. So these are equal. And then f of 5, which function do I plug into for f of 5? Top, middle, bottom. the bottom function. So again, I'm going to get that negative 9 over 25 minus 35 plus 6. So that's 6 minus 10. So that gives me a positive 9/4. And it turns out it's continuous here as well. All of those are equal. So what we're saying here, my final answer would be that f of x is continuous everywhere except x equals to -2 and x equals 6. And this was removable, and this was infinite. And this technically is my actual final answer. Are there any questions about this?